Okay, so today we're going to talk about the OpenGL pipeline. So, the OpenGL pipeline has four major steps. The first one will be the vertex shader, the second one will be the clipping, the third one is the rasterization, and the fourth one is the fragment shader. Now, two of these are basically under the control of the manufacturer, which are the clipping and the rasterizing. But you get control over the vertex shader and the fragment shader through programmable shaders, usually in GSLS file. Okay, so let's look at them separately. So let's first talk about the vertex shader. Let's suppose you want to draw a house, right? Well, basically the house is made of vertices. So here's all our vertices. These are what's generating the house. Now, this house is in some coordinate system, and each vertices has basically coordinates. These coordinates are stored with what we call attributes. So every vertex has a set of attributes. For example, the location of the points. Now, OpenGL is focusing only on a very small part of the space, which is the -1, 1, -1, 1 square at the bottom left of the screen. So this is the OpenGL space. This is the space where it's going to draw. So our house is not currently at the right place. So one thing we can do is try to rescale the house and move it right where we want it on the screen. There we go. So now we have that very small house, which is exactly where we want on the screen. So far, this house is really only a bunch of vertices with their attributes. So the only thing we're really doing is changing all the attributes so that their coordinates is fitting in that screen. So this is basically the task of the vertex shader, taking all the attributes and doing all the motion of the objects so that it's going to be in the part of the screen that we want. So translation, scaling, and rotation, this is the most important part of the vertex shader. So the vertex shader moves objects around, translating, scaling, rotating by acting on their vertices and provides information for rasterization. Okay, so let's take our house again. Now we're in this very nice OpenGL space, -1, 1, -1, 1, in X and Y axes. And the next step is actually clipping. Clipping means that we need to cut part of the house that won't be on the screen because there's no need to draw it. But what is the house really? So far, the house is just a bunch of points, which we probably sent as a set of triangles. So the house is a whole bunch of triangles. So the clipping job at this stage, which is under control of the manufacturer, is to basically try to break down those into smaller triangles so that we can eliminate the part that is not on screen. So we can focus only on the part that will be on the screen. Again, those details depend on the manufacturer, so they're kind of out of your control. So now we have our house, which is in where we want it in the screen, ready to be drawn. So the first thing is to basically color all that house, and the first step for that is rasterization. So rasterization basically means creating pixels for every single spot of those triangles. So let's take our triangle and let's make it a bit bigger. And basically there's some sort of pixels behind. We don't call those fragments, but really you can see fragments as a pixel. So we have that grid over here, and the goal now is to fill that grid with pixels everywhere where they should be drawn. So the rasterization process is basically creating all those fragments that are small pieces where basically we expect some pixels to be drawn. Note that all these pieces have a copy of the attributes. So for example, if you pass some variables between your vertex shader and fragment shader as flat, for example, in this case, we may have passed green. So if there was a color attributes for every corner, we can use one of those corner and basically copy the information for every fragment. So every fragment will know they should be green. Alternatively, you can interpolate some variable, for example, texture coordinate, and then each fragment would have a different coordinate that could be used for applying a texture. So once this is rasterized, we have all these very small objects that are not drawn yet. They're just notations on the screen for which something needs to be done. And this is where the fragment shader actually kicks in, where the fragment shader is basically acting on each of these fragments and executing the program and applying a color or texture. In this case, we would just want to draw our triangle green, so basically the fragment shader is going through every fragment and coloring them green. Now, you repeat the process for every triangle, so you get this for the whole house, and basically you get your nice house, which is where you wanted on the stream. If you want more details about the OpenGL pipeline and what kind of algorithms in the background is going on to do the clipping, to do the rasterization, you should read carefully Chapter 6 of your Interactive Computer Graphics textbooks. Have a good reading.